Hello, today we look at the development lens in structure and the importance it holds in any structural design. And we'll be looking at that with respect to the pillars, the beams, and the slabs. And we try to make this as easy as possible so everybody can understand it. So let's get into it. Well, okay, we have looked at how you can design your foundations very well, bring out your estimates. Now we are going to look at the components of the structures, and we'll be starting with the beams and the pillars. Okay, so now let's say we are designing by what we call going by our limit state design. Please, for those of you who don't understand, I am going to try to make this to be as explicit as possible. Okay, so even if you don't understand, you are going to understand by the end of this video. Now, according to the limit state mode of design, we always design for collapse and serviceability. I'm going to explain all these terms, please. Even if you don't understand, I will explain them to you. Collapse and serviceability. Okay. Now, what this simply means is that you design the structure in such a way that if you are designing for collapse, you are designing the structure in such a way that it can withstand all the load that will be put on the structure. Okay. So all the load that the structure is going to carry, you design it so that it can carry that. And then for serviceability, it means you are not only designing the structure to be strong, but you also want it to be serviceable, so it can also, like, be workable. Now let me demonstrate that by this example. Let us just imagine that this is a slab. Okay, by a slab I mean a floor. This is a floor that has been designed. So let's say this floor has been designed, and for collapse it is okay, which means it is strong. Okay, this is very strong versus very solid. Whatever load we put up here according to the design is okay. But now let's say someone comes to live on this surface. Let's say this is somebody who wants to live here, and maybe this slab is on a cantilever. Okay, it's on a cantilever, and maybe when it's windy or I don't know something, it becomes it vibrates or it shakes. When that happens, you're going to see that it's going to make this person or whatever occupant is there to be uncomfortable. Okay, now even though this slab is strong, we know that it's strong, we have respected all the values for collapse, we have designed it to be very solid, but serviceability, looking at the serviceability, it is not strong enough. Let me demonstrate by showing another example. Let us still say this is a slab, and this is someone who is living here. Now let's say in the course of the design, we discover that in order to carry out the structural calculations to design this to really be strong in terms of the collapse, we have to pass a column in the center here. So there's a pillar that is passing in the center of this building, like so. Now you discover that when the occupant of this building comes here, he's going to find this to be like, it's not really going to look good, because how do you position your furniture like this with a pillar at the center of the building? It doesn't really look good. So you have respected the collapse, it is strong, but it is not really serviceable. So you have to make sure that you respect these both values when you are designing. You're not only designing a structure to be strong, but you also want to design it in such a way that it can easily be used. You provide space. Okay, so now how do you now go about this? The first aspect that we are going to be looking at is what we call bonding. Okay, now what is bonding? I'm going to demonstrate that by using an example. Let's say this is your pillar that is coming down like this, and then you have a beam that is attached to it like this. Okay, so if this is your pillar that comes down straight, and then you have the beam that projects out like this. Now what is happening here? If you have a rod in this, of course you know that this pillar and beam are all reinforced concrete. Okay, what is reinforced concrete means? It's a mixture of rods and cement and sand and all that, rods and concrete. Okay, that is what makes up the pillar and the beam. So of course, in the pillar you have your rods that are coming down like so. You have your rods that come down like this, and then of course also in the beam you also have rods that come like this, like that. And of course the rods have to come and they hook with the pillar. Okay, like so. It all depends on how the details of the structural from the structural engineer are. So what does this mean? The bonding comes in the sense that this rod has to come and hook with the rods that are in this pillar. Okay, that is what creates the bond. Okay, now let's say you try to pull this rod. Let me just extend the rod this way. Let's say you try to pull this rod out like this, let's say by maybe a force T. Okay, or you apply a tension or a tensile force like we normally call it. If you are trying to pull this, you are going to see that it is not going to come out. Why is that not coming out? That is because of three very important factors. Okay, the first factor is let's look at the friction. Okay, and the second factor is because of the interlocking. I'm going to explain this. Interlocking like that. And the third factor, that's the last but not the least, is because of the chemical adhesion. Okay, so what does this mean? First, friction. When you pull this rod out like this, you are going to see that since it's a mixture of the rod and the concrete, there's going to be a frictional force that is going to act this way. As you can see, the frictional force will act this way, thereby preventing this rod from going out. Okay, so no matter how much you pull it, you see that this rod cannot come out of this beam. Why? That is because of this frictional force which is being exerted by the concrete that is embedded with this rod. Okay, now the second point, interlocking. You can bear with me that of course rods, you see when you look at a rod is not smooth, it is always rough. Okay, yeah, the surface of the rod is always rough. Now that is like that so that it can also bind with the concrete. Okay, yes, if it was smooth, well, of course you can bear with me, it will be easily to pull out. So that interlocking that is created by the roughness of the rod and the concrete is what also keeps it in. Okay, and then of course the chemical adhesion. Chemical adhesion just means that like in the cement, there are some chemical properties of the cement that also helps to bind the rod and the concrete together. Okay, so now let's look at one point here. We all know that for a beam, this is a beam. Okay, now let's say this beam is loaded, it's been loaded like this, and this load can either come from the slab, because as you know, each slab that you find, like the slab I was talking of up here, is being carried by the beam. Okay, now it is this beam now that transfers the load to the pillar. And you have to understand one thing: all these components of a structure, from the beam to the pillar right down to the footing, they are not there to carry the load of the building. Nothing carries the load of the building. They're just there to transfer the loads. So the slab collects the loads from the furniture or from the occupants or from whatever thing, it sends it to the beams. The beams takes that, sends to the pillars. The pillars takes that, and until it goes down and it is at the foundation where you have the footings, and then the footing takes that now and transfer the load safely to the ground. So you are just providing a passage where these loads can continuously be transported. They are being transferred until they finally get to the ground. Okay, it is not like any of these components carries the load and holds them. No, it is just a transfer of load. So how do you ensure now that this beam cannot fail? Now, the first thing is to make sure that you provide an accurate length of this rod. Okay, so this rod that is going to come in here and hook with the pillar has to be of an accurate length. Okay, what do I mean by that? If the length that you give for this rod is not accurate, you are going to discover that the load, because if it is long, it is going to transfer it here, but if it is not long, you're going to discover that the load will be carried by the beam itself. And when it is carried and not transferred, when the load is carried by the beam and it is not being transferred accurately to the pillar, you start seeing that cracks might develop at the beam here, or worst case scenario, it can lead to a whole total collapse of this structure. And when even you see cracks start developing, you have to know that that is a problem, and with time that structure is going to have a problem. So you have to make sure that you provide accurate length of your rod to hook with the pillars. Okay, because it is only after I do that now that it is going to now transfer the load safely to the pillars take those now, the transfers now to the footings, and the footings now sends those loads to the ground, and your structure is very safe. So how do you now know the accurate length to hook here in the pillar? That we're going to be looking at in our next tutorial. And in the next tutorial now, we are going to be talking about development length. When we are talking about development length now, then you are going to find out how you can estimate and know the accurate length of rod that you have to give in your beams in order to hook it very well with the pillar in such a way that the structure is safe for adequate transfer of the loads that are being exerted on the beam, be it from the floors or the occupants of the building, or maybe from furniture again and all that. So that is it for this tutorial, and please, if you like this tutorial, make sure you always like and share them, and subscribe to all of our channels, because we produce tutorials like this all the time, so that you can always receive notification for these tutorials. Thank you, and see you in the next tutorial.